Uttarakhand Public Service Commission, UK PSC, Deputy Superintendent of Police, Police Telecommunication, 2024 question paper solutions, part 3, that is from question number 61 to question number 90. First question, the variant of linked list in which none of the node contains null pointer. So correct option is C, circular linked list. This circular linked list is a variant of linked list in which none of the nodes contains a null pointer. This is because the last node in the circular linked list points back to the first node, creating a loop structure. In a circular linked list, all nodes are connected to form a circle. All nodes are connected to form a circle. There is no null at the end. Correct option is C. Question number 62. Write the parity bits for the following 3-bit message codes if even parity generator is used. In the question it has been mentioned even parity generator. In digital communications, this even parity ensures that the total number of ones is even, while odd parity ensures that the total number of ones is odd. And this even parity and odd parity are used to detect the single bit errors during data transmission. In case of even parity, if number of ones is even, then parity bit value is 0. If number of ones is even, then parity bit is 0. If number of ones is odd, then parity bit value is 1. In case of odd parity, if number of ones is odd, then parity bit value is 0. Otherwise, it is 1. So given 0 double 1, 0 double 1, and we need to write the parity bit. So here in the question it has been asked even parity. So the total number of 1 should be even. So it will be 0. Next is 111 and parity bit we need to write. So here the total number of ones is odd. To make it as even, we need to write 1. So the total number of ones is even in this case and even is as well as in the both cases. So correct option is 0, 1. It is B. Next question, question number 63. Virtual inheritance used in C++ programming to avoid dash. So this virtual inheritance is used to avoid the multiple copies of base class data members to be inherited into the derived class. Correct option is B. This virtual inheritance in C++ prevents multiple copies of base class data from being inherited into the derived classes. This technique is useful when inheriting from multiple classes, also known as multiple inheritance. This virtual inheritance in C++ is a technique that ensures a single copy of a base class is inherited by the derived classes. It is used to solve diamond problem which can occur when multiple classes inherit from a common base class. The correct option is B. Next question, question number 64. Zener breakdown occurs through. The options are avalanche effect, electron-electron collision, impact ionization, all the above. So let us see the differences between Zener breakdown and avalanche breakdown. This Zener breakdown occurs at low reverse voltages, typically below 5 volts, and this Zener breakdown is caused by strong electric field that breaks the covalent bonds in semiconductor, releasing electrons, and this process is called quantum mechanical tunneling, and this happens only in heavily doped diodes, whereas this avalanche breakdown occurs at higher reverse voltages. Impact ionization is a key mechanism where the high energy electrons collide with the atoms, knocking out more electrons, and these electrons further collide with the other atoms, leading to a chain reaction or avalanche effect. Next, this avalanche breakdown happens in lightly doped diodes with wider depletion region. Therefore, this avalanche effect, electron-electron collision, impact ionization, all are option A, B, C, all are related to avalanche breakdown. The correct answer should be none of the above. This quantum mechanical tunneling, Zener breakdown occurs in reverse bias with high reverse voltage across a heavily doped PN junction diode and causes quantum mechanical tunneling of electrons from valency band of p side to the conduction band of n side. There is no such tunneling mechanism in avalanche breakdown, whereas tunneling of electrons takes place in Zener breakdown. The temperature coefficient is positive for avalanche breakdown, occurs only in diodes with breakdown voltage is greater than 6 volts, whereas the temperature coefficient is negative for Zener breakdown, occurs with breakdown voltage less than 6 volts. Avalanche breakdown happens in lightly doped diodes, whereas Zener breakdown occurs in heavily doped diodes, and these characteristics are more sharp for Zener diode, whereas it is not sharp for the avalanche breakdown. This Zener effect Zener effect occurs in heavily doped semiconductors, resulting in narrow depletion region when the reverse bias voltage reaches to the breakdown voltage, typically below 5 volts or 6 volts. A strong electric field is generated across the depletion layer. This intense electric field is powerful enough to break the covalent bonds and release the free electrons through quantum mechanical process called tunneling, and the released electrons contribute to large reverse current causing breakdown without damaging the diode. So no tunneling in avalanche breakdown, whereas quantum mechanical tunneling happens in Zener breakdown. The correct answer is none of the above. No option is correct. This option A, avalanche effect or impact ionization or electron-electron collision, all are related to avalanche breakdown. Question number 65. The purpose of biasing BJT is, correct option is A, to set the operating point. So the transistor biasing, BJT is bipolar junction transistor. The transistor biasing refers to applying external voltages to the transistor terminals, that is external DC voltages to the transistor terminals, to establish a proper operating point. This proper operating point or Q point for its amplification and switching operation. The purpose of biasing in a transistor to establish a stable operating point known as Q point or quiescent point to ensure proper functioning of transistor in various applications, that is amplification purpose and switching on off switch. Different types of biasing in transistors are fixed bias, collector to base bias, voltage divider bias, emitter bias, self bias. Similarly, for a diode, biasing is a process of applying external voltage, that is DC voltage, to control the direction of current flow. In diode, there are two types of bias. One is forward bias and reverse bias. Biasing of a diode is defined how the diode is being connected to the battery. These external voltages are DC voltages. Correct option is A. Next question number 66. Choose the correct relationship in respect of intrinsic semiconductors. So Ni square is equal to NCNV e power minus Eg by kT, where Eg is energy band gap, Nc is effective density of states in conduction band, Nv effective density of states in valency band, Nd is donor concentration of atoms, Na concentration of acceptor atoms, Ef is Fermi energy level, Ec is lowest energy level in conduction band, Ev highest energy level in valency band. Correct option is D. Next question. A thyristor can be used as a, option A, resistor, option B, switch, option C, amplifier, option D, power source. So thyristors are semiconductor devices that can be used as a controllable switches in high power applications. Thyristor cannot be used as amplifiers because thyristors have two valued switching characteristics. This means they can only be fully on or off, unlike resistor which can be in between on and off on state. So this thyristor cannot be used as an amplifier because the thyristors have two valued switching characteristics, either on or off, and there is no intermediate characteristics between on state and off state. Next, thyristor cannot function as a resistor. It is a semiconductor device that operates in an on state or off state but not providing the variable resistance. And the thyristor is not a power source. It simply controls the flow of power from supply to load but does not generate the power by itself. Hence, correct option is B. Thyristor can be used as a switch but cannot be used as a resistor, but cannot be used as an amplifier, and cannot be used as a power source. Next question. When the drain current is less than IDSS, JFET acts like a. So these are the this given graph shows the VI characteristics of junction field effect transistor. The regions of this JFET are cutoff region, ohmic region, saturation region, and then breakdown region. This JFET acts like a off switch in cutoff region, on switch in saturation region, and it acts like a voltage variable resistor in ohmic region and constant current source in saturation region. So in this saturation region, this JFET acts like a constant current source. In ohmic region, JFET acts like a voltage variable resistor, off switch in cutoff region and on switch in saturation region. The correct option is resistor. So when a drain current is less than IDSS, so here drain current, this drain current axis, when it is less than ID axis, so this is a region. This JFET acts like a voltage variable resistor. Correct option is B, simply resistor. Next question. For how many degrees of input signal does class C power amplifier conduct? So let us see the comparison of different power amplifiers. Class A power amplifier, Class B, Class C and Class AB power amplifier. In the question they have asked Class C power amplifier. For Class C power amplifier, conduction angle is less than 180 degrees. Correct option is B. On the cutoff point, the position of Q point is below the x-axis. For Class C power amplifier, efficiency of Class C power amplifier is high, whereas for Class A power amplifier, conduction angle is 360 degrees, Class B it is 180, and Class AB it is between Class A and Class B. So for the question, for Class C power amplifier, for how many degrees the input signal does conduct is, it is less than 180 degrees. Next question. What is the maximum conversion efficiency of Class B push-pull power amplifier? The maximum conversion efficiency of Class B power amplifier is 78.5, whereas for Class C power amplifier, the maximum conversion efficiency is 90 degrees. For Class B, it is 78.5 degrees. For Class A power amplifier, that is series fed Class A power amplifier, it is 25%. For transformer coupled Class A power amplifier, the maximum conversion efficiency is 50 degrees. As per the question, for Class B push-pull amplifier, the conversion efficiency is 78.5. Maximum conversion efficiency is 78.5. Next question. When AC base voltage is too large, if it is too large in BJT, then AC emitter current is. So the AC emitter current is distorted. When AC base voltage is too high for a CE amplifier circuit, the AC emitter current becomes distorted. That is, high signal causes distortion because of VI characteristics of BJT is non-linear. Due to nonlinear VI characteristics of bipolar junction transistor, the AC emitter current becomes distorted. In a BJT, the operating point is an active region. The emitter current generally flows from input base voltage. However, when input AC voltage becomes excessively large, the transistor may enter into saturation or cutoff region during the parts of input cycle. This is a nonlinear This nonlinear behavior results in distorted output current instead of clean sinusoidal waveform when the transistor is driven beyond these limits, leading to clipping and harmonic distortion. The correct option is C. When AC base voltage is too large, then the transistor may enter into saturation or cutoff regions, so which results in nonlinear behavior and the output is distorted. At low frequencies, the coupling capacitor produces decrease in dash in an amplifier. It decreases the voltage gain of an amplifier. So coupling capacitor decreases the voltage gain of an amplifier at low frequencies because the reactance is high. So generally the reactance of capacitor is XC is equal to 1 by J omega C. If coupling capacitance is less, the reactance is high. This means more signal voltage passes from, so this means more signal will be lost and less signal voltage passes from one stage to the next stage. At low frequencies, this capacitive reactance increases. This increase in XC drops the signal voltage across the capacitor and reduces the circuit gain. As signal frequency decreases, the capacitor reactance increases and gain continues to fall, reducing the output voltage. Whereas in mid frequencies, the coupling capacitor provides constant reactance and in turn the voltage gain remains constant. In mid frequencies, voltage gain is constant. So at low frequencies, the reactance of coupling capacitor is quite high and hence very small part of signal passes from one stage to the next stage. The reactance of CE is also high at low frequencies. Due to these two factors, voltage gain falls at low frequencies. Whereas at high frequencies, the reactance of coupling capacitor is very small and it behaves like a short circuit. This increases the loading effect of next stage and serves to reduce the voltage gain. Even at high frequencies and low frequencies, the voltage gain is decreased. Whereas in mid frequencies, the voltage gain of amplifier is constant and the effect of coupling capacitor in this frequency range is such as maintaining a uniform voltage gain. So here voltage gain is uniform at mid frequencies. In the question, at low frequencies is given, therefore due to coupling capacitors it reduces the voltage gain on an amplifier circuit. Next question, question number 73. Which doping technique is used near to the room temperature? So let us see this two doping techniques, differences between diffusion and ion implantation. These two are the doping techniques. This diffusion is used at higher temperatures, whereas ion implantation it is performed at lower temperatures. Correct option is A. Ion implantation is a doping technique which is used near the room temperature or at low temperatures. So this diffusion is used to form deep junctions. Diffusion is used to form deep junctions, whereas ion implantation is used to form the shallow junctions. Diffusion is one of the main techniques used to introduce impurities into the semiconductor. In diffusion, particles are spread through random motion from higher concentration region to lower concentration. Ion implantation involves bombardment of substrate with the ions accelerating to higher velocities. So let us see these differences between diffusion and ion implantation. In diffusion, the movement of particles, the movement of atoms from higher concentration to lower concentration, whereas in ion implantation, high energy ions are physically embedded into the substrate. Precise control over dopant depth and concentration is possible in ion implantation, limited control in diffusion process. So correct option is ion implantation is a technique used at room temperature. Next question. It is not possible to fabricate dash in a monolithic integrated circuit. So a diode can be possible to fabricate, a capacitor can be possible to fabricate in monolithic IC, resistor is possible to fabricate, whereas inductors and transformers it is not possible to fabricate in a monolithic integrated circuits. So reasons are mentioned. So inductors are not easily fabricated in IC form because they are bulky. Inductors are bulky, difficult to accurately manufacture an integrated circuit, and requires isolation. The other reasons are size and space constraints, low inductance values, magnetic core laminations. This IC fabrication does not support magnetic materials. This IC fabrication does not support magnetic materials, leading to air core inductors with reduced performance. Parasitic effects, heat dissipation and power loss, fabrication complexity and cost, limited magnetic coupling. Due to the following limitations, inductors and transformers, due to above all limitations, inductors and transformers are often used as a discrete components in circuit designs, especially for applications requiring high power and low frequency of operation. This inductive circuit has a non-planar configuration which typically has spiral shape. This particular non-planar configuration thus prevents IC fabrication process to integrate large inductive circuits as a part of IC devices. The conclusion is inductors and transformers it is not possible to fabricate in an IC form. Next question. What is the advantages of VLSI? Very large scale integration. So the advantages of VLSI are miniaturization, high performance, low power consumption, cost reduction, increased reliability, enhanced functionality, portability, energy efficiency, improved design flexibility, and faster time. Rapid prototyping. VLSI enables rapid prototyping and production of electronic devices. The correct option is D. All the above. High speed, cost reduction, miniaturization. B of the question paper. Question number 76. In the circuit shown in the figure, the current response I of t is. So the given circuit consists of R, resistance R and capacitance C. The time constant of the circuit is tau is equal to R C. The capacitor for t is equal to 0 plus at initial state t is equal to 0 plus the capacitor acts like a short circuit. So capacitor is short circuit, therefore the equivalent circuit is this is the equivalent circuit V of delta of t, current I of t, resistance R, capacitance acts like a short circuit, and the initial voltage initial current I initial is V by R. So initial current is V by R. At t is equal to infinity, as t tends to infinity, that is in steady state, the capacitor acts like a open circuit. So the equivalent circuit is resistance R. This is capacitor. Capacitor is acting like a open circuit. Initial state capacitor is acting like a short circuit. And the applied voltage is V delta of t. Now in open circuit, the current is 0. So the final current is 0. The expression for current I of t is I final minus I initial e power minus t by tau. Tau is RC, time constant of circuit. Given RC circuit, time constant. So here the final value of current is 0 and the initial value of current is V by R e power minus t by tau. So that is V by R e power minus t by RC. The correct option is A, V by R e power minus t by RC. This is the current response I of t for the given circuit. Next question. The voltage transfer function of a network shown in the figure is. So this is a network. Let A be the node A and B be the node B. So resistor 4 ohm resistor is 4. 1 farad can be written as capacitance. C farad capacitance can be written as 1 by Cs in Laplace transform, and inductor can be written as Ls. Here capacitance is 1 farad, 1 by Cs, that is 1 by S. In Laplace transform representation is 1 by S. A, B are the node points. This is 4 ohm, 1 by S ohm, and inductor is 2S ohms. Apply KCL at node B. At node B, V naught 1 by S ohms plus V naught of S, that is V naught is V naught of S. Analyzing the circuit in S domain, V naught of S minus V in of S by 2S is equal to 0, because the voltage at node B is V naught of S, V output voltage. Voltage at node A is V in of S. And solving this, V naught of S by V input voltage, output voltage by input voltage is 1 by 1 plus 2S square. The correct option is C, the voltage transfer function. Voltage transfer function. The ratio of output voltage to input voltage in S domain, that is 1 by 1 plus 2S square. Correct option is C. Next question. A network is said to be linear if and only if. So a network is considered as linear circuit if it has to satisfy two principles, that is principle of additivity and the principle of homogeneity. If the principle of additivity states that if input x1 of t produces output y1 of t and input x2 of t produces y2 of t, then combined input x1 of t plus x2 of t produces the response y1 of t plus y2 of t. Similarly, if input is scaled by a amount, then output is also scaled by the same amount. So that is, a network is said to be linear network if it satisfies the both principle of homogeneity and the principle of additivity. And so this additivity also called superposition. So correct option is D. Next question. Hybrid parameters in terms of Y parameters. These Y parameters are short circuit parameters. Hybrid parameters are H parameters. So the relation between Y parameters and H parameters are this H11 is equal to 1 by Y11. H12 is minus Y12 by Y11. H21 is Y21 by Y11. H22 is delta Y by Y11. Correct option is B. So this is H parameters in terms of Y parameters, Y parameters in terms of H parameters. Both are given. These Y parameters are short circuit parameters and H parameters are hybrid parameters. Similarly, there are Z parameters or open circuit parameters, ABCD parameters or transmission parameter, inverse ABCD or inverse transmission parameters, and inverse hybrid parameters. Their inputs, their variables, and the relation between the variables are given in the image. Correct option is B. Next question. The Routh-Hurwitz criterion gives information about absolute stability. RH criteria gives information about absolute stability. So let us see this RH criteria. This RH criteria is used to determine the absolute stability but not relative stability. This RH criteria is an algebraic method that analyzes the stability of control system by checking the roots of characteristic polynomial of a linear system. This RH criteria states that system is stable if all the system is stable if all the roots of first column have same sign, that is all roots of characteristic equation have negative real parts. If any root lies in the right half of S plane, then the system is unstable. Whereas root locus method is used to find the relative stability of a system. Root locus is a graphical method used to analyze the relative stability of a control system, as a gain varies how the location of system pole changes with respect to feedback gain. The question: RH criteria for absolute stability and root locus method for relative stability of control system. Correct option is C. Next question: the voltage having a Laplace transform V of S is 4s square plus 3s plus 2 by 7s square plus 6s plus 5 is applied across a 2 Henry inductor. So given for inductor L, its Laplace transform is Ls ohm. The value of inductance in terms of resistance is Ls ohms. L is in Henry. For L Henry, its resistance is Ls ohm. Voltage V of S is given and resistance is Ls. The current I is equal to V of S by resistance, that is 4s square plus 3s plus 2 by 7s square plus 6s plus 5 divided by Ls. Inductance is 2 Henry, that is 2s, and this is I of S. And in the question they have asked to calculate the initial value of current. In the question it has been mentioned to calculate what is the value of current in the inductor at final value or steady state value. So by final value theorem, I of infinity is equal to limit s tends to 0 s into I of s. So that is limit s tends to 0 s into I of s. Substitute I of s here. Limit s tends to 0 s into I of s is 4s square plus 3s plus 2, 7s square plus 6s plus 5 divided by 2s. Here s get cancelled and substitute the value of s is equal to 0. So therefore we will get 2 by 2 into 5, it is 1 by 5 ampere. So that is I of infinity is 1 by 5 ampere. Correct option is B. So the final value theorem expression is mentioned here. I of infinity is equal to limit t tends to infinity I of t or limit s tends to 0 s into I of s. Next question: a source can emit a plane wave. So that source is a plane source. So plane wavefront is produced by a plane wave source, and point source can produce a spherical wavefronts, and the wavefronts of linear source is cylindrical. This is because all points equidistant from a linear source lie on the surface of a cylinder, and the direction of propagation of wavefront is same as the direction of propagation of a wave. This point source produces spherical wavefront, linear source produces a cylindrical wavefront, plane source produces a planar wavefront. So point sources, linear sources, plane sources, and wavefront. The definition of wavefront is a locus of all particles in a medium that is vibrating in a same phase. The direction of propagation is perpendicular to wavefront. So point source creates spherical wavefront, linear source creates cylindrical wavefronts, and distant sources creates plane wavefronts. Distant sources for sources. So correct option is A. Plane source can emit a plane wave. That is distant sources. Next question. Question number 83. A vector field is said to be irrotational if a vector, the curl of a vector A is rotational vector. So when it is said to be rotational vector, the curl of vector A is rotational vector. 83. A vector field V is called rotational if curl is 0. So the definition of curl is curl of a vector A is a rotational vector with magnitude being that maximum rotation of A per unit area as the area tends to 0. The vector field A bar is irrotational if its curl is 0. So curl is 0 means del cross A bar is 0. Similarly, vector field A bar is solenoidal if its divergence is 0. For vector field, it is irrotational if curl is 0 and solenoidal if its divergence is 0. Correct option is A. Next question. The electric field inside the conductor will be. So inside the conductor, the electric field is 0. The electric field is 0 inside the conductor. Just outside the conductor, the electric field lines are perpendicular to its surface, ending or beginning on the charges on the present on the surface. Correct option is A. Next question. The Gauss law in differential form can be written as. So the Gauss law in differential form for electric field is del dot D is equal to rho V in differential form, or surface integral of closed surface integral of d bar dot ds bar is equal to open volume integral of rho v dv, that is equal to charge enclosed. It is in integral form. The Gauss law for electric field in integral form and differential form, where d is electric flux density coulomb per meter square, rho v is volume charge density. This Gauss law states that flux leaving any closed surface is equal to charge enclosed by that surface. Question number 86. Which of the following is Ampere's law? This Ampere circuital law, del cross H is equal to J bar plus dou d bar by dou t. This is in differential form, whereas in integral form, closed line integral of H bar dot dl bar is equal to open surface integral of Jc plus dou d bar by dou t into ds, where Jc is conduction current density. Similarly, we know the relation between B and H. B is equal to mu H, magnetic flux, where B is magnetic flux density in Tesla, H is magnetic field intensity ampere per meter, mu is permeability of the medium. Therefore, del cross H is equal to J bar plus dou d bar by dou t. In terms of B, del cross B is equal to mu naught J bar plus dou d bar by dou t. Correct option is D. Next question. A distortionless transmission line is one in which attenuation constant is. So distortionless transmission line. So the attenuation constant is independent of frequency. For a distortionless line, attenuation constant alpha is independent of frequency and phase constant beta linearly depends on frequency. Similarly, for a distortionless transmission line, the condition is R by L is equal to G by C, that is Lg is equal to Rc. The line is said to be distortionless if output is exact replica of the input. Similarly, for lossless line, R is 0, resistance is 0 and conductance is also 0. For distortionless line, the Z0 phase velocity alpha, Z0 phase velocity and attenuation constant alpha are independent of frequency, which can be realized as Lg is equal to Rc. So the correct option is C. The attenuation constant is frequency independent. Next question. The most commonly used null detector in power frequency AC bridges. So it is vibration galvanometer. These galvanometers are used as a detectors in DC circuits where the frequency of source is 0. So basic galvanometer is used as a detector in DC circuits where the frequency of operation is the frequency of source is 0, but for AC bridges we are using vibrant galvanometer, headphone and tuned amplifier at different frequencies. This vibrant galvanometer is used in the frequency range from 5 Hz to 200 Hz, headphone from 250 Hz to 4 kHz, and tuned amplifier detector from 10 Hz to 100 kHz. The correct option is vibration galvanometer. This moving coil galvanometer is an instrument. Option A, D-arsenal galvanometer. So this moving coil galvanometer is an instrument which is used to measure the electric currents. A D-arsenal galvanometer is a type of galvanometer that measures small currents and voltages in the circuit. A ballistic galvanometer measures large currents, large amounts of currents that are flowing in a circuit. And vibration galvanometer, it is a device that detects alternating currents. And tachometer, it is used for measurement of RPM. This tachometer is also called RPM gauge. It is a device that measures the rotational speed of a shaft or disc. For the question, the correct option is it is not D-arsenal galvanometer, ballistic galvanometer, tachometer. The correct answer is vibration galvanometer. Next, question number 99. Kelvin double bridge is best suitable for the measurement of resistance, in particular for the measurement of low resistance. And the methods used for the measurement of low value of resistance are ammeter voltmeter method or VI method, Kelvin double bridge method, and potentiometer method. The low resistance is the value of resistance less than 1 ohm. Medium resistance is resistance value lying between 1 ohm to 100 kilo ohm, whereas high resistance is the value of resistance is more than 100 kilo ohms. This Kelvin double bridge is used to measure very low resistance, typically below 0.1 ohms with high accuracy. This Kelvin double bridge is a modification of Wheatstone bridge that eliminate errors caused by lead resistance and contact resistances. Correct option is A. Next question. A digital to analog converter. So DAC is given, digital to analog converter with full scale output voltage of 3.5 volts. Given full scale output voltage is 3.5 volts and has a resolution close to 14 millivolts. Given the resolution is 14 millivolts and full scale output voltage is 3.5 volts. And the bit size is, in the question they ask to calculate the value of bit size. So we know that resolution is equal to full scale output voltage VFS by 2 power n minus 1 into 100. This is percentage resolution. So substitute the values of VFS. So resolution is 14 millivolts, 14 into 10 power minus 3, and full scale output voltage is 3.5 volts by 2 power n minus 1. So 2 power n minus 2 power n minus 1 is equal to 3.5 by 14 into 10 power minus 3. That is n is equal to, or 2 power n is 1 plus 3.5 by 14 into 10 cube. So on substitution, the value of n is 8. The correct option is D.